What is a programming? Is this a programming? Is this a programming? Is this a programming? And if my function doesn't function, is it still a function? What if you really like her, but you're just not her data type?
It's not you, it's me.
And if my decimal number sinks, is it still afloat? All this and more on Programming with... This is how the course is going to work. You're going to open a new document and save it in your OneDrive called GCSE Summer Python Task. It's going to be broken into 7 sections with 1 surprise section at the end. Juicy. You're going to receive titles as we go, heading 1, 2, and 3, just like you do in the normal lessons. You know how to do this. You're not silly. In each section, you're going to be making notes and coding. Tippity tappity tippity tappity. Finally, this is my favourite part of this whole course. Every section is going to finish with a set of programming challenges. They will be ranked easy, medium, and hard. And I'll explain which ones that you have to do later on. I'd like for you to do all of them, but there will be a minimum requirement. You are going to mark these according to the mark schemes that I give you. This is really important, like really important. You must save this to your OneDrive before you start. This will not be uploaded to
school website.
You are going to share it with me as a OneDrive link, and you say, Mr. Singer, why do I have to share it? Why can't I love
school website.
Why can't I use that? The answer is very, very simple. We're going to be using version history. All the cheaters in the room just felt a bead of sweat go down the back of the neck. Version history allows me to see every single change that's made and how it was made to your document, i.e. if you cheat in any way, I will know. This is an independent task. Won't take too long. You could probably do it in a day or 2 if you try. I don't want to see anybody cheating, and I will know if you have. Why won't it input? Why won't it input? My key's not working. Why won't it input? And if my variable never changes, is it still a variable? This is our first section's first titles. As you can see, section 1, inputs, outputs, and variables, data types. You're going to write down these headings in your OneDrive Word document. Hello, Editing Singer here. Just a quick note in case you've never done this before. On Word at the top, you've got these beautiful headings up here, and you think, Mr. Singer, why do I have to do that? Watch. Look up there at the top, heading 1, 2, and then if you keep going, there's usually 3. Heading 1, heading 2, and you think, Mr. Singer, that doesn't make a difference. What's so good about that? Go up to View and click Navigation Pane. On a Mac, if you're on Windows, do Control F and click Headings. You can then see that we get this beautiful, organised list at the side of our document, so that you can pop up and pop down to wherever you've been before. This is going to be so important when you do the really difficult coding challenges later and you need to reference your earlier work. Don't skimp out on the headings. Second thing before I go, make sure that you make the notes properly, i.e. the keywords, write them. You're allowed to screenshot my code examples as we go through and we do the examples together, that's fine. But I want to see the keywords and all the programming terminology written by you in a beautiful document
with all those headings. All right, take it back to pre-recorded singer. Bye.
H1 means heading 1 and H3 means heading 3. Go. After the titles, the next thing is always going to be the key coding words and definitions. These are key terms that you've got to understand to be able to do this part of the course. Let's look at these four for inputs, outputs, and variables and data types. Input, that's something that goes in. Print, that's something that comes out. Equals, that's for assignment. For example, num1 equals 5. Easy peasy. Data type, that's going to be the type of variable. String, integer, float, char, bool. We've done this already, but you know how it goes. Getting those definitions now.
Don't forget your highlighting.
Now it's time for coding examples with Singer. This is where we go over to Trinket and we, start coding. So if you haven't used Trinket before, pop over to Google and open up a fresh Trinket. Let me show you how to do that. Right, everybody, go over to Google and type in Python Trinket 3. Make sure you type in the 3, that'll become very important later. When you load that up, you'll see two lovely sides. The left-hand side is where we're going to be doing our coding. This is where we type our code. On the right-hand side is called the output window. This is where all the stuff that the code outputs gets outputted. Let's start with the basics. Let's do inputs and outputs. We're going to start with the easiest thing in all of programming, the basic print statement. Print to my nan means something coming out on paper in the printer. Print in programming means something coming out on the screen. See the similarity? Type print with a lowercase p. Python is a case-sensitive language, and if you do stuff with capitals in the wrong place, it will die. And we don't like death. Print, bracket. This is you saying what you want to print. Now, when we're dealing with strings, which are like words and text, a collection of characters, you're going to do quotation marks because strings are done in quotation marks. Think about it. When you quote someone, you do quotation marks. When you're quoting text, do the quotation marks. We can say whatever we like in here. It could be, hello, Graham. Now, nothing's happening. Nothing's happening. We need to make it, just like I need to do more, because my BMI is getting so high, we need to make it run. Click the little play button here to make your code run. Fantastic. We got it. Hello, Graham. Amazing. If I wanted to do something on another line, I could just do another print statement underneath. Graham is wonderful. And run it. Amazing. Works a treat. Incredible. Now, the next thing we need to do is inputs. But before we do, we need to talk about
Variables.
Variables are how we store our data. Now, I'm going to zoom in here. You can call a variable whatever you like within reason, but there are a few rules. No numbers at the start, no spaces, and generally start with a lowercase letter and every other word goes uppercase. This is sometimes referred to as camel case. So if I wanted a variable called name, for example, this might store a person's name. Let's say we wanted to input into that variable. Let's say we wanted the person to be able to type in their own name. How would we do that? First, we say the data type. As you remember from the previous slide, scroll up if you've forgotten, there are 5 data types. And in this case, a name would be a string. For that, we type str, short for string. We do another set of brackets, and inside that, we do input. Amazing. One more set of brackets, and inside there, we're going to place a prompt. This is what will come up on the screen to ask the user for that particular input. For example, enter your name. Amazing. Zoom out a little. If we run this, we see it now comes up with enter your name, and we got a little flashing cursor. Amazing. My name is Graham. It's not really Graham. I'm going to press enter, and nothing happens. What do you remember from what we just did that lets us output something on the screen? What if we want to output Graham? Maybe even a nice message saying, your name is Graham. We need a print, don't we? Print. Your name is. And then if we want to put something on the same line, we have to do a comma.
Comma.
And then, now here's where a lot of students make a really stupid mistake. They put name in quotes. Eek! That's not going to work, is it? Let's see why. Go for it. Oh. By the way, Trinket can be a sausage sometimes if it ever just doesn't run. Just press the play button again. Enter your name. Graham. Your name is name? What do you mean? I wanted it to be name the variable. Why is it just coming out with the word because of the quotes. Get rid of the quotes. And this then matches the variable name. Notice how they're the same color. If you ever get stuck, the color coding on Trinket is beautiful. Beautiful color coding. Let's give it a run now. See what happens. Let's enter our name. Graham. Get in! Come on. Can't argue with that, can you? Right, we've done text. Amazing. But Mr. Singer, aren't computers like just massive calculators? Isn't everything... When I play Fortnite and I shoot someone, aren't I just like minusing from their health based on the gun I've used, the ammo type, and the part of the body that got shot? Yes. Numbers matter even more than text when it comes to computers. So let's do numbers. If I want to make a variable that stores a number, I can do num1. By the way, don't forget to screenshot these as we go. The code examples section of your notes is for these code screenshots that we've done. It'll really help you when you're doing the coding challenges later to have some screenshots of the code that we've done together. Don't forget to screenshot them. If you don't know how to screenshot because you're on a Chromebook and you don't know how to do it, just Google screenshot Chromebook. Google is your friend. Num1 equals. Now, before we had str, which stood for well done, hola, soy Dora. However, if we want to do a whole number, for example, what would we do? Remember the keywords. A whole number would be an integer. Beautiful. Int, then input, and then a prompt. Like, for example, enter your number.
Cucumber. Vitamins, minerals, very high number.
Outstanding. Let's enter our number. What did I forget to do? Got my print, didn't I? Silly man. Silly man. So, what we're going to do is print your num is, comma, remember the comma, chameleon. Then, num1, not in quotes. Let's give it a run. 5,000. I'll take that. Fantastic. What if we wanted to do a decimal number? What data type would I need to do for a decimal number? Does anybody know? Yes, the opposite of sync. Float. Beautiful. Let's give it a go. Now I can do any number I like, including decimals. Could do 4.777. Get in! Come on. Now, Python doesn't really do chars, so you don't have to worry about it. You can just do a string with one letter. But it does do booleans. Now, booleans are a little bit different. They're a bit weird, especially when we're taking them in a text input box. So follow along with me. We're going to do, let's say, adult, because I know most of you, you've played GTA 5, even though you weren't an adult. So let's do a check to see if somebody's, let's say this is the Xbox storefront, and we're checking if they're an adult. Adult equals bool, because that's our data type. Editor Rich put up a picture of George Boole on the screen in his beautiful jawline. Bool input. Are you an adult? Now, we could print this in the same way as we normally do. You know, you are an adult, and then adult. So it'll either say you are an adult true, or you are an adult false, right? Now, I want to show you why that's not going to work. We run this, it says, are you an adult? And if we put false, it's going to say true. That's a lie. That ain't true. Sad. Because we're using a Boolean mask, all it's going to check is if there's something there or if there isn't. If there's something there, it's going to give us true. If there's nothing there, it's going to give us false. So what we can do as a little bit of a workaround here is put in brackets blank for false, true for true. Could even put enter. Blank for false, true for true. Let's give that a try. Run it. Remember, trinket. If it doesn't work, just run it again. Are you an adult? Enter blank for false, true for true. If I enter blank now. False! Get in! Come on. However, if I wanted to do what 97% of you do when you go on GTA 5 and lie, I could put true. Boom! We got it. These are your coding challenges for section 1. They are so easy, so nice and gentle to get you into the scheme of things. You'll see that on the right, we've got some E's. These are absolutely mandatory. So are the M's. Now, the difference is the E's, I'm expecting flawless results, perfect marking. Because as long as you've just watched that challenge and take some screenshots, you'll be absolutely fine. The M's, I want everybody to attempt and mark properly. If you cheat, I will know. I've got version history. But the H's are for those of you that want to do this for a job. The H's are for those of you that want to be in my A-level class in about a year and a half's time. Those are the ones that are going to push you, and they're going to get much harder as we go. I'm going to put a timer up on the board now. Only give yourself as long as the timer says, otherwise you might get stuck on a challenge for ages. I mean, if you really want to, you can keep working on it, but use this as a guideline. Time starts now.
Really?
Now we'll go through the mark scheme to those challenges. So, for 1A, I was expecting something like this. Print Graham. Nice and easy, and Graham popping up on the right-hand side. If you did that, give yourself a mark. Well done. Next one, we were expecting a variable called name with an input that was cast as string, str. Enter your name, or any suitable prompt there would have been fine. Print name, not in quotes, but just name itself. And over here you can see we've used Billy as an example, and Billy came out the other side. Awesome. For 1C, I was expecting two inputs going into two separate variables, name and age. The first one, string, is str input, enter your name, or whatever you like, printing it. Or you could have done a nice little message at the start there as well, like your name is. That would have been awesome. And age is very similar, except we're going to do enter your age, and we're going to cast it as an integer because it's a whole number. And then we print age. Awesome. 1D, we were going for the same again, but we were adding at the bottom, you see there, money. Now money,
Wonga.
money, float, because it's a decimal number, right? Float, input, enter your balance. Lovely. Section 1E, we were looking for the same again, but we were going to add employed at the bottom as a boolean, true or false. Again, entering something for true and nothing for false, just like in the example. Finally, we're going to print that in a nice, neat order. At the bottom, you see there, we've got print statements lined up. Your name is, with the comma and name. You are age years old is a nice way of doing it. Remember, multiple commas there because we're putting a string either side of the variable. You have so much money in pounds, because if you put the pound symbol on the data type, it's no longer going to be a float, is it? It would be a string. because a string is a collection of characters. Silly sausage. Always put your symbols or your context around the variable, not inside it. And the last one, you were employed, and that'd be true or false. Give yourself a mark out of 6. Boom.
If my decimal number sinks, is it still afloat? If I don't complement my floating point binary number, is it a 2's insult? They say you can't divide by 0, but you can. Watch.
Maths is an extremely important discipline. Comes from the Greek mathema, meaning that which is learned. It's also a language. Fascinating language. I'm not even joking, Google it. However, today we're going to do some simple maths. We're going to be doing maths in Python. The only real challenge with maths in Python is remembering the symbols and a couple of difficult sort of methods, but they're really easy once you get down to it. It's just memorizing what they do, really. These are your titles for this section. Get them in. Go.
And it's a natural thing, of course. I mean, I could work out all day, and obviously
These are our key coding terms for maths. Now, you'll see there's a lot there, but it's definitely worth remembering. Plus is plus. That's easy. Minus is minus. It's also easy. Star might be a little bit hard to remember, but if you ever forget, just look at the num lock near your keyboard, the number pad at the side, and you'll see that star is over there next to plus and minus. That helps me remember. Forward slash is a single divide. That's missing on there, which is annoying, but I think I ran out of space because of the next 3. Equals is assignment. Equals is assignment. So remember, in Python, there are 2 forms of equals. There's a double equals and a single equals. Single equals means assignment. We'll do double equals when we get to selection. These are the 2 hard ones. Listen. The percentage sign is modulo division. Now that sounds like a big scary word, doesn't it? Modulo sounds like a superhero character or maybe a side character from Big Hero 6's sequel. No, modulo means remainder. Modulo means remainder. If you're using modulo division, you're going to get a remainder back. Okay, there's a nice little example there. 5 modulo 2 would give us a remainder of 1. Now, double slash is integer division. Integer division. Remember the last lesson where we learned what an integer was? An integer was a whole number. That's right. Well done. Whole number. Good. Integer division is just a normal divide, but if it's got a decimal at the end, it just chops it off. Gone. Boom. Obliterated. And those are the symbols that we need to know. Time for coding examples with Singer. We're going back over to Trinket now. Lovely. Let's start by a little bit of recap from the last session. How do we input a number, a whole number specifically? You got it. We make a variable, call it num1. Always a nice start. Equals, because equals means assign. We're going to give num1 a value. Then we're going to say the data type, integer, for example, in this case. Then we're going to say input, and we give it a prompt. Enter your first num. Now, I'm a bit lazy because I'm a programmer and we have very, very high BMIs generally, and we're quite lazy people, so I'm just going to copy and paste that. Then I'm going to do num2, enter your second number. Don't even have to type it twice. Copy and paste is your friend. As long as it's your own work, it's not plagiarism. Now we've got two numbers that we can use. All right, we'll let the user input them. Let's do some maths. Now, if I want to add these together, I can do that because you know that plus means add. You're not silly. But where are we going to put it? We're going to put it in a new variable. In this case, called answer. Answer equals num1. And what was the symbol for addition? Plus. Num2. Is this going to print anything on the screen though? Is anything going to come up? Nah. We need to print it, don't we? Print. What's going to go in those brackets? Is it answer like that with quotes? Is that right? No! No, it's not. That is going to print the word answer because it's a string. We want to print the answer variable. Enter your first number. Let's do 50. Enter your second number. Let's do 100. That should output 150. Excellent. What if we wanted to do a minus? All we'd have to do is change our little operator there from a plus to a minus. Let's give it a go. Let's do 30 minus 10. We get 20. Excellent. You all right with that? If we wanted to times them together, we could do that. Do the star. Let's do 5 times 5. And we get 25. Excellent. Finally, we'll do divide. Remember, divide is slash, forward slash specifically. And let's run it. Enter our first number. Let's do 10. And 10 will divide by 2. So our answer should be 5. Amazing. The last two operators are a little bit funky. Let's learn about them. If we do a percentage sign and we divide two numbers together, our first number, in this case, will do 5 and we'll divide 5 by 2. Now remember, the percentage sign is modulo division. So it gives us the remainder. Remainder 1. Amazing. This is great for working out if a number is odd or even. Really helps too when we do iteration later. What if we divide two even numbers together? You know, like 4, and we divide that by 2. I'm expecting 0. We get 0 because there's no remainder. The last operator you need to know for your GCSE is called integer division. This simply cuts off any decimal part of the number. But to do this, we should first change our data type, shouldn't we? Just for consistency's sake. How do we do that? We're not going to have integers. What data type are we going to have for a decimal number, children? That's right, we're going to have a float. Well done. Let's divide two decimal numbers, just for the sake of it. Let's make something really heavy on the decimals. 5.5 divided by 1.5. That would have like a lot of decimal numbers, right? Let's run it. 3. Who knew? Where did they go? Where are the decimal numbers?
Where are they?
Integer division.
Making a choice.
Where are they?
We can't find them anywhere. Send out a missing persons report. No, they're gone because we used integer division. And if you want to basically chop off the end of that, you want to just cleave off those decimal points, you just use integer division. Last thing to show you, if you want to do more than two numbers, that's super easy too. Just grab your number and make more. Let's have a num3. change that to enter your third number. And we could do num1 times num2 times num3. If you wanted to do num1 times num2 and then times that by 3, you can use brackets just as you would in maths, like on a calculator. So we'll times these together and then times it by 3. Enter our first number. Let's do 2 and times it by the second number, which can be 2. Oh, I did 1, never mind. 2 times 1 would be 2. And if we times all those by 5, so 2 times 5, we should get 10. Amazing. That's Python Maths for OCR GCSE. It's very simple. Your coding challenges, however, are going to stretch you a little bit. So this is section 2 and the coding challenges. Remember, all of them, all the way up to both mediums, are mandatory. You must attempt all of them. The H's are for those of you that want to do this at A level. I'd expect that. By the way, lots and lots of house points for those who manage to do all the hard challenges and the mediums as well. These are your challenges. Again, if you get stuck, go back to the code examples that you wrote earlier, that you screenshotted earlier, and you'll smash it. Don't worry. Do your best. Go.
Hey!
The mark scheme for section 2 is as follows. Follow along with me. For the first number, we were going to add up two user-inputted integers, and we were going to print the answer. So we got num1 and num2, casted them as integers, as OCR calls it, and we got an answer variable, added them together, and printed the answer. Lovely. Next one said decimal numbers, didn't it? So you're not going to use an integer. You're going to use a float. Look at that. First number, second number, added them together, and I used 7.5 and 2.5. Amazing. 2C was to divide two floats that are user inputted. So it's the same code as before, but instead of a plus, we've done a slash, which is what we use to divide. 2D was using modulo division to give us the remainder. And as you can see there, the only difference was to add a percentage sign. Nice and easy. Whoop-ow, whoop-ow, whoop-ow.
Smack the lip. Whoop-ah. Drop down. Snap. Ah!
The final one was to use integer division. Same code as before, but we use a double slash. Nice and easy. Gives us the number without the decimal. Fabulous. This last one was the only challenging one on there, really. So we're going to take in minutes as an integer because you don't really have 0.2 of a minute. You'd use seconds, wouldn't you? Getting this answer was tough. If you didn't manage it, don't stress, but learn from this. Hours becomes minutes, integer division, 60. Follow along. Minutes becomes minutes, modulo division, 60. Then we print the hours total and the minutes total. And you can see there, I entered 150 minutes, which all of you know is 2 hours and 30 minutes. Maths. Done. If I'm thirsty, I drink. If I'm hungry, I choices. Choices. Selection is all about choices. Now, let's take a look at what we're going to be learning today. But before we do, a little bit of a public service announcement. You'll notice the next section is called the 3 programming constructs. However, we are only going to be talking about 2 of them. Thinking, Mr. Singer, why would you deny us of that information, Mr. Singer? And the answer is very clear. Sequence is so easy, it would physically harm me to try and teach it to you for more than about 8 seconds. So let's do sequence very, very quickly. If the code needs to be in order to work properly, then it's using sequence. That's all it means. For example, if you do num1 equals 5 and then do num2 equals num1 times 2, it's not going to work if it's the other way around, is it? Because you don't know what num1 is yet. That's how easy it is. Let's go on to the second of the 3 programming constructs. Selection, just as you saw in the transition video there. It's when we make choices. These are your titles. Go!
What am I? Oh. Really tall? No! I'm an ogre! You know, grab your torch and pitchforks. Doesn't that bother you? Nope. Really? Really?
The key words for selection are few but thick. There's a lot of definition here. Make sure you write them down correctly, or you're really going to struggle in the programming challenges. If is the first one we're going to do. This is where we make a decision in our code. For example, num1 equals 5. If num1 is greater than 10, print your num is bigger than 10. Easy peasy. Else is whatever happens if the number, or if the variable in any case, doesn't match that condition. So if the number wasn't bigger than 10, the else would be done. Switch and match. Sometimes it's called switch, sometimes it's called match, sometimes it's called case. Switch and case are the terms that OCR use, but in Python, we have to use what's called match. It's like the equivalent. So this is kind of like an advanced version of an if statement, where if you've got lots and lots of options that are all pertaining to one variable, like down here, for example, we've got wheel count. If there's only one wheel, we're dealing with a unicycle. Calling all the clowns! What about if there's 2 wheels? Bicycle, yes. What about 3 wheels? Triangle, 3 sides, 3 wheels, tricycle. And then the bottom one here, case underscore colon, that's like the else for a match statement. So if any of the previous cases are not true, that is the one that will be done. Before we move on though, these are the comparison operators as well that you're going to need for this section. This section has a BMI similar to me. It's quite chunky, okay? So, on the left, we've got our comparison operators. And on the right, we've got our Boolean operators. Remember George Boole from earlier? George Boole. On the left, comparison operators. Remember, 1 equals means a sign. But 2 equals is what we use when we're comparing. You know, saying, is this equal to this? 2 equals for comparison, 1 for assigning. Exclamation mark equals is not equal to. So, you know, if password is not equal to database password, login denied, for example. Less than, if you didn't do the crocodiles at primary school, I can't help you. Less than or equal to, greater than, less than or equal to, easy peasy, it's the crocodiles. On the right, this is what we use when we want to join multiple ifs together in the same line. Like, for example, if username equals database username and password equals database password, print logged in. Nice and easy. Not and or, again, very similar to that. Just before we start the next section, you must use Python 3 for this section or your code's not going to work. Just make sure that when you went on Trinket, you typed in Python 3 Trinket, Python 3, and yeah, click on that because the match statement does not work in Python 2. Let's get to the coding examples. Skadoosh.
The whooshy thing hold. Oh, you know this hold. You're bluffing. You're bluffing! Shifu didn't teach you that. Nope. I figured it out. Skadoosh.
Right, everybody. We're back with our good friend, Mr. Trinket. Let's start with some basic selection. And to make it easy on you, we're going to do numbers. Let's do num1 equals. Now let's do an integer, just to be safe. And how do I input an integer? First I cast it by saying int, then I do input, and then my prompt, like enter num1. Beautiful, okay? Let's do an if statement with this integer. Let's check if the number is bigger than 5. If it is, we'll say your number is bigger than 5. So we'll do if num1 is bigger than, remember the crocodile eats the number that is bigger. If the number is bigger than 5, notice the colon at the end. If you miss your colon, your code won't work. And this is just as important now. When you press enter at the end of a line, notice what happens. Does the cursor go all the way to the left? It doesn't! Senpai, no. Why aren't you over there? Because of a little something called indentation. Indentation. Indentation shows ownership. If you see an indent, you're saying that the code in the indent belongs to the statement above. Allow me to show you what I mean. If we do print your num bigger than 5, this looks like it works. We've got no errors. Fantastic. We can even test it if you like. Go over here, enter num1. Oh, I need to enter it. Let's go for 10. Your number is bigger than 5, right? All is well. But if I was silly and I forgot my indentation, bad things would happen. Watch. It's dead. Look at that. Look, it even tells us on the error screen. Indentation error. Expected an indent block on the if statement. It can't get much clearer than that, can it, folks? No, 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 no. Always remember, by the way, that on the right-hand side, when you do get an error like this and it goes red, just read it. And generally, it'll tell you exactly what's wrong. In fact, even Tom with the line number, line 4, indentation error, expected indent block. So all I have to do is indent. By the way, pro tip, tab on your keyboard automatically indents for you. I don't advise you trying to press space because you'll never know if you get it exactly right. Always press tab. If you don't know what tab is, it's the one just above the caps lock. It looks like, a little couple of arrows. It's tab. Tab. Okay. On to the else. What if somebody doesn't enter a number bigger than 5? What if they enter 0? Nothing happens. Has the code broken? Has it gone on holiday? Is it enjoying the Spanish sunshine? No, it's not. We just didn't code it. We need to do an else. Else, this is what will happen if that condition is not true. Print. Your num not bigger than 5. Let's give it a go now. We can even put minus 1,000, can't we? And it's true. Your number is not bigger than 5. Fantastic. What if we wanted to make the number greater than or equal to? We just add an equals to our crocodile. So if num1 is greater than or equal to 5, we can print this out. But what do we have to change as well? That's right. Hola, soy Dora. We need to change our print statement, don't we? Your num bigger than or equal to 5. Your number is not bigger than or equal to 5. Let's give that a try. If we pop 5 in now, it should say your number bigger than or equal to 5. Fantastic. Easy peasy lemon squeezy. Now that's all well and good for numbers, Mr. Singer, but a lot of things that we do on the internet, when we're typing in passwords and usernames and all sorts, aren't numbers at all. They're usually strings. Let's make a string. How do we input a string? You remember? Let's give it a name. Let's do password. Password equals str for string, input, and we do our prompt. Enter your password. Now we're going to need something to compare it to. So before I do password, I'm also going to do stored password, or you could put DB password for database. Stored password equals, and what should we store it as? What should I think Graham the Onion. Graham the Onion. Now we're going to compare the two and see if the user enters it correctly. If password is, how many equals am I going to put here? Two. Good. 2 equals, because 1 equals is assignment. 2 equals is comparison. If password equals stored password, we know that the password is correct. We'll print logged in. Else, print no. Go away. Ha ha ha. Let's give it a try. Let's put in the correct password. Graham the Onion.
How do we dice an onion? Big onion. Look at that. Woo! To the good onion. Good onion is a heavy onion.
This is a 6-pound onion.
And go. Get in! Come on. Can't argue with that, can we? What if we wanted to do it a different way? What if we wanted a username and a password, actually? Yeah, let's do that. Let's add stored username equals short man, and username as an input as well equals string input, enter your username. Amazing. Let's tidy this up a bit. That looks really pretty to me. Feel free to screenshot that, by the way. If password equals stored password, logged in. Otherwise, no. Go away. What do we need to add here? Because we're checking the password, right? What else have we got to check? We've got to check the username. So let's add to this if statement using our Boolean operators. Which of the 3 Boolean operators do you think we're going to need? That's right. And. Amazing. Because we're going to check the username and the password. username equals stored username. Let's give it a try. Let's do it incorrectly first. Bob, Rachel. No, no, no! Go away. But what if we type it correctly? What if we do Shortman and Graham the Oyon? I spelled Shortman wrong. There's a capital. Even teachers make mistakes. Sometimes I put a capital there because I'm stupid. There we go. That's your username. Shortman with a capital M. And Graham the Oyon. Yay. Superb. Just before we move on to switch statements, do you know about string manipulation methods? I know we've done them in class, but if you're here from somewhere else or you've just come across this YouTube video, string manipulation methods are amazing. They can convert strings in all sorts of ways, like making them all uppercase, lowercase, a search and replace function. Editor, just put some of those on the screen now so people can see what they do. What we're going to do with one of those manipulation methods is make it so that our username is case insensitive. What does that mean? That means the password is still going to be case sensitive. They've got to get the case right. But just like with the Shortman example from before, we don't want the username to be case sensitive. Most usernames aren't. Neither are email addresses. So what we're going to do is, and username dot upper, so it's going to convert it to uppercase just temporarily for the check, equals stored name dot upper, again, just temporarily, making them both all uppercase so that it doesn't matter what case the person used on the input, it should still work. In fact, let's prove it. Enter your username. Let's do Shortman, like that, so we know that it's wrong. And password, let's do Graham the Oyo.
Get in!
Result. All right, the last thing we're going to do in selection is called a switch statement. Switch, case. In Python, you use the word match, but in the exam, it's the word switch and case. I'm going to teach you how to do that now. Check this out. First, we need a variable to, check. So let's do the vehicle example together. Let's do wheel count. And we'll set that to an integer that the user inputs. Enter your num of wheels. Amazing. Then what we're going to do is type match wheel count. And then underneath that, we're going to do our case. In the case that wheel count is 0, we're going to output error. Because 0 doesn't really make sense unless it's a hovercraft or a hovercraft or a helicopter maybe, I don't know. Case 1. Now, come on, you circus enthusiasts. What's that going to be? Clowns ride them? Unicycle. Good. Case 2. We could do a bicycle, right? Is it bicycle or bicycle? I always forget. Bicycle. And then just to finish off, we'll do case 3. Tricycle, like a triangle. Let's run it. Enter your number of wheels. If we put 0, we should get error, right? Get in. Now, you remember from the keywords, we also need a case in the case that none of those are entered, kind of like an else is with an if. To do that, we do case underscore print invalid input. If I type in 3000, amazing. If I type in -3, I was getting back, that's amazing. Case statements are really easy and dead efficient once you know how to use them. Time for your coding challenges. Alright everybody, these are your challenges. They start nice and easy. There's even a login section there that we kind of just did together, so it's not too difficult at all. The medium one will involve using modulo division that you learned in the last lesson, and the hard ones are really tricky, but I'm sure you'll have a lot of fun with it. Do your best. 3, 2, 1, go!
Editing Singer here. This is just a reminder for you to click like, click subscribe, enable notifications, and for the algorithm, comment down below onion.txt. That's onion.txt.
All right, the mark scheme for section 3. Let's do it together. The first one said, allow the user to input an integer called num1. The program uses an if statement to check if num1 is greater than 10. If it is, print your number is greater than 10. Otherwise, your number is not greater than 10. Let's take a look. Enter the input, check if it's greater than 10, do the output, and do an else statement. Easy peasy, lemon squeezy. The next one, I believe, was adding two floats together, which is why we've cast this one as a float. Let's check it out. Take them in as floats with input. Money equals num1 add num2. If money is greater than or equal to 100, we know we're good. Mega dosh. However, if not, get back to work. Easy peasy. This one was a fun one. This was essentially what we did on the practice earlier, so it shouldn't have been too hard for you. We're going to have 4 variables. 2 of them are hard-coded, i.e. they're set in the program with an equals and no input statement. And the other 2, the attempted username and attempted password, are user inputted. Now, you can call these whatever you like, but you would have needed 4 variables. Or, I mean, you could have used an array if you've gone that far ahead, but yeah, 4 variables or an array. String casting on the inputs as well. If attempted username equals stored username and attempted password equals stored password, login successful. Else, print get out your dirty hacker. You could have also done it backwards and done attempted username is not equal to and attempted password is not equal to That would have also been acceptable, and done it in reverse. This was the first tough one. If you remember rightly, modulo division from the last lesson allows you to check if a number has a remainder when it's divided by something. Knowing that odd numbers, when divided by 2, have a remainder, and even numbers don't, allowed you to use an if statement with modulo division to check if 0, we've got even, otherwise print odd. And of course, the opposite would have also been acceptable, like if divided by 2 not equal to 0, print odd, else print even. So, a little bit tough, but easy once you get your head around it. First example of a case challenge. You can see there, we take the number of sides as an integer, not as a float. You're not going to have 3.5 sides. Match whatever you called that variable with case 3, 4, 5, 6, 7, all the way down to 10. Triangle, square, but easy peasy, lemon squeezy. The next one involved a bit of verification and a nested case statement inside an if. Or you could have done it with like a Boolean variable check, whichever you liked, as long as you got the same result. So this was basically making sure that the user did input between 3 and 10 inclusively. You see that if there? See the if? Notice that the match is indented inside it. This match is never going to execute unless this if statement is true. You get me? They have to do a correct input. And you'll notice at the bottom, if you can see, because PowerPoint's doing this stupid thing where it covers up the text, it says print error at the bottom. So there you go.
While teeth dirty, brush teeth. For x in range 0, 10, 1, eat onion.
Hello. We're back. Iteration's a funny thing. I cannot remember what you said. Could you please reiterate for me? To reiterate is to say again, right? Iteration is to do again. So, we're going to do the third programming construct and probably the hardest, iteration. Lovely. These are your titles. Go.
Another one. Another one. Another one.
Only 2 major keywords for this, which is nice, but again, they are chunky. Count controlled, condition controlled. Count controlled, condition controlled. Count controlled, for. Condition controlled, while. Basically, if you want something to repeat a certain number of times, you use a for loop. If you want something to repeat while a certain condition is true, use a while loop. In the example we've got here, if you wanted to just go up in increments of 1 all the way up to 10, you could use a for loop. Make sure you get that in nice in your notes. But down here, our while loop, it's going to keep repeating while the counter is less than 10. You might think, Mr. Singer, what's the difference betwixt them? Let's imagine that you were doing a login system. Let's say while password is not equal to stored password, keep asking. Do you know what I mean? Or while ammo is greater than 0 and right trigger is being held, shoot, if we're playing a disgusting game like Fortnite. You know who you are.
Another one.
Coding examples with Singer. Right, everybody, we're going to start with the conditional loop. Let's see if you can remember what that is. Good, it's a while loop. The problem with a while loop is if we want to iterate while something is true, we need something to check against. Let's do a counter. We'll start our counter at 0 because, again, in computer science, we don't waste no numbers. If 0's there, we're going to use it. Counter equals 0. While counter is less than, let's do 10, we're going to print counter. What's wrong with that? What do you think that's going to print? That's right, that's going to print the word counter. That ain't good. We don't want a string. We want it to tell us what the number is. Now, I really advise you not to run your program when it's in this state because you will kill Trinket. I'm going to do it just to show you what happens, but this is going to be really bad. So look, we've done while counter is less than 10, we're going to print counter. But does counter ever change? As you can see, we now have infinite zeros on the right-hand side, and that's never going to stop. What do we need to do with our counter every single time our code loops around, every time it repeats? What do we need to do to make it count up? Remember the maths that we did. Counter equals counter plus 1. Let's run it. Beautiful! Come on. What if we wanted it to count up in 2s? We could do counter plus 2. Amazing. 5s? We can do that. Amazing. What if we want to count down from 10? We could start the counter at 10, and we could say, while the counter is greater than 0, counter equals counter minus 1. And we could go downwards. Watch. Whee! Fantastic. So, basically, while loops are super useful for anything conditional. And we'll do it now. We'll do it now. So one of the most common examples of a while loop is a login system or user entry into anything, especially in your exam. So let's do a PIN number for a phone. Let's set the PIN to 1, 2, by the way, whenever you're doing passwords or pins, even though they're numbers, they're actually strings because integers cut off zeros at the start. And if you do a phone number and you cut off the 0 at the start, is it going to work? Nah, usually strings, even though it's kind of weird. If you don't have to do maths to it, store it as a string, basically. Let's do 4, 5, 6, 7. Okay, that can be our phone pin. And we'll do attempted pin equals blank, so that we've got a variable to work with our while statement. Now, we're going to do while attempted pin is not equal to. How do we do not equal to? What symbols do we use? Come on, remember from last lesson. While attempted pin is not equal to pin. Good. Do not forget your indentation. Never forget your indentation. And your colon at the end. Look at that, look at that. Look at that beautiful gap there. That's good. That means that this code belongs to the while loop. Isn't that wonderful? So we'll say wrong pin, try again. But what do we need to do every single time they get it wrong? That's right. We're going to import attempted pin inside here. What data type would it be? String. That's right. Input. Enter your pin. Pun.
Teddy! Mr. Bean begins to feel intimidated by the crowd and starts to panic. Unsure what Mr. Bean will do if he loses control, Superman spawns in a Great Wall of China.
While attempted pin is not equal to pin, we need to do something. We need to do a check first. An if statement, a bit of selection. We're going to do if attempted pin is not equal to pin. We're going to print login failed. Try again. And otherwise, which means it was correct, we're going to print login logged in. Okay? There's one thing we're missing here though. Where do we actually ask the user to enter their PIN. Where do we do it? Because if we do it up here, outside the while loop, it's only going to happen once. Watch. Attempted PIN equals string input, enter your PIN. We run that. Watch this. Enter your PIN. Even if I do 3, 4, 5, 6, we just get infinite login fails. It's not good, is it? We need to give them a chance to enter it again. So whenever you want to keep allowing somebody to enter something, you must place it inside the loop, preferably at the start. Let's get rid of that. Let's run it again. Enter your PIN. Let's do 1, 2, 3, 4. Yes! Come on, what a win. Let's do 8, 7, 0, 0. None of those work. What will work? 4, 5, 6, 7. Boom! Come on. Result. What if we want to give the person only 3 tries to get their PIN right? What are we going to need to keep track of how many wrong attempts they've had? What data type would we use to store it? To write an integer, let's have attempt count. And we'll set that as an integer. We'll set it to 0 because they haven't attempted anything yet. And down here, when it's not correct, what are we going to do to attempt count? That's right, we're going to increase it. Attempt count equals attempt count plus 1. Fantastic. However, at the moment, we don't know how many attempts we've got left. So let's add a print statement. Print, you have attempt count attempts left. That's how many we've got. Let's give it a try. You have 1 attempt. Actually, no. You have 3 minus attempt count. Amazing. Amazing. We can see we've got this many attempts left because you get 3 in total, minus that from attempt count, and that's how many we've got. Okay. But it's just going to keep going. Look. I don't have minus 3 attempts, do I? That'd be pretty crazy. We need to add an extra condition to our while loop to make it stop. What Boolean operator are we going to have to pop in here? What Boolean operator? That's right. And attempt counter is less than 3. So 0, 1, 2. There's our 3 goes. Let's give it a go. Oh, sorry, attempt counter. Not attempt counter, it's just attempt count. Let's give it a go. Enter PIN. 4. One last go. Graham. Wonderful. Amazing. And that is everything you need for while loops. Absolutely everything. For loops, otherwise known as count-controlled loops. In many ways, for loops are actually a lot easier than while loops because they only take up 2 lines, really, 1 line actually for the actual loop code. Check it out. We don't need a separate counter. It all gets bundled into one, but the code is very dense. It's very thick. It's like a Big Mac. There's lots of meat jammed into a small space. Let's do for x just represents a counter, like x in maths, just a number. For x in range, that's the keyword. Now check this out. 0, that's where we start. 10, that's where we end. And 1, that is our increment amount. So if you want to comment at the side, start, end, increment. That's how I always remember it. Oh, don't forget the colon. And what else do we need on the next line? We need our indentation. Let's do print x and run it. Boom! Look at that. Wonderful. Fantastic. If we wanted to say your counter is before that, we could just pop it in there. Your counter is, and then do a comma. Your counter is, ba-boom. If we wanted to take this up to 1,000, ba-boom. 10,000. Might be a bit too big for drinking. Page unresponsive. I killed it. So, for loops. If you want to go forwards or backwards, it's very, very easy. You could do start at 100, go down to 0, and then -1. Let's do that. Wow, start at 100, go down by 1 every time, get yourself down to 1. Okay. For loops is super, super easy. They're very nice. As long as you remember what each 3 of these numbers mean, you'll be absolutely fine. Start at 0. If you want to go up to 20 and go up in 2.5s maybe. Do that. Can't do that because it only accepts integers. Just go up in 2s. Boom. Easy peasy. Lemon squeezy. Your coding challenges for this section are beefy. Whew. The first one's a while loop. The second one is a for loop. And the third one is a while loop that checks the input every time it goes around. The 4D and 4E are actually quite easy considering they're medium questions. But the last one, the login system with a maximum of 3 attempts and a Boolean value to check it, is really tough. You're going to be fine. Do your best. Go!
While Teddy has accepted his fate, Jimmy is determined to break his way out. Naturally, he activates his powers of extreme obesity.
Right, the mark scheme for 4A. You could have done it one or two ways. You could have done counter is 0, pop it up to less than or equal to 50 on your while loop, and gone up by 1 every time. Or you could have done less than 51. You'll notice if you just do less than 50, it doesn't actually count to 50. Because it's going to stop at 50, isn't it? Because you're saying while it's less than 50. Hee big brain. 4B is just a basic for loop that again goes up to 50. You would have had to put 51 in there to get that right. Make sure you read the question properly. 4C, nice and easy. We kind of did a nice example of this. Again, the opposite way around would have been fine, but we'll go through. Store a pin in a variable. I should have stored that as a string. I'm a naughty man. Attempted pin equals int input. What's your pin? Again, it's consistent, at least my error. While attempted pin is not equal to pin, wrong pin, try again. Attempted pin equals int input. What's your pin? Welcome. To be honest, I prefer the way I did this in the example before, like, for example, setting attempted pin to nothing and having an if statement in there. But whichever way you would have preferred is absolutely fine. Yeah. The next one, going decrements from 1,000 downwards, you would have needed 1,000, 0, and -5. Easy peasy. For 4e, we're looking at the counter being set to 0. While counter is greater than 0, we're going to print the counter and decrement it by 2 every time. This was the tough one of the bunch. We're looking for a few variables here. Attempt counter and logged in being variables. Okay. While attempt counter is less than 3 and logged in is false, we're going to do attempted username, attempted password, string input, etc. If attempted username equals stored username and attempted password equals stored password, logged in equals true, print logged in. Otherwise, wrong details, you have guessed incorrectly so many times. Attempt counter equals attempt counter plus 1, or anything similar to that would have been totally acceptable. You've just done iteration. Ciao. Arrays. Question is, we've got multiple variables, lots of them. Maybe we're collecting Pokemon or Fortnite skins. Maybe we've got a list of student names in a class. What's the best way of storing them? Because it's not in lots of variables. Student 1, student 2, student 3, student 4, student 5, student 6, student 7, sadness ensues. Don't want that. We're going to learn about arrays today. An array is a collection of variables, and these are your titles. Go.
I miss my wife, Tails. I miss her a lot. I'll be back.
The key words for this are juicy, fruity, and citrusy to boot. An array is a collection of variables. Check out the EG there. Names equals Graham, Greg, and Gloria. Notice the commas separating them. To separate elements in an array, you use a comma. And also notice that the brackets are remarkably square. They ain't round like your teacher. They're square, like a box. Square brackets are used for arrays. To print any element of an array, we have to do the array name, square brackets, and the index number of that element. For example, Graham would be index 0, Greg 1, Gloria 2, etc. Whenever we use the word element in this case, we are talking about the data itself. For example, Greg, Gloria, and Graham are elements. However, the index is where that is. So, for example, Graham is at index 0. You got it. A 2D array is the last thing we'll do in this bit, and it's an array of arrays, a collection of collections. And to do that, we just do an array and then put square brackets around it and separate them with commas. It's exactly the same, except instead of variables going in the gaps, you have arrays. Coding examples with Singer. Let's start with an array of names. Keep it simple. Let's do names. We declare it in the same way we do a variable, just with an identifier. And then we do an equals to show assignment. Square brackets, dense brackets, not curvy brackets, dense brackets. And then we do the names that we're interested in. For example, Graham and Gloria and Gran. Now, to output any of these, we're going to need print, aren't we? Because that's how we output. But what are we going to do? What do we say? Because if I put names, Graham, that's not going to work. We're going to get an error because it's expecting an integer in there, an integer to represent the index. For example, if I wanted to output Gloria, what index would I place in there? Make sure your brackets are square here, by the way. If I wanted to output Gloria, what index would I place there? 1. Good. Check it out. Gloria. If I wanted Graham, I'd do 0. We happy with that so far? Easy peasy lemons. However, what if our array isn't strings at all? What if our array is actually numbers? Let's say percentage scores. So percentage grades. Let's say these are all the students in a class and these are the grades they got. Could do somebody got 20%, somebody got 40%, somebody got 100%, somebody got 15 and 30 and 90 and 40 again. So we've got 0, 1, 2, 3, 4, 5, 6. Okay. If we wanted to print the number 100, we'd do print percentage grades and pop in 2 because 0, 1, 2. Happy with that so far? What if we wanted to do a little bit of maths between them? What if I wanted to add all of these up and get an average? Yeah? Yeah? You see where I'm going with this? So, if I wanted to add them all up and get an average, I'd have to get a variable called total. And we'd do percentage grades 0, add percentage grades 1. Just for the sake of fitting this on a single line and shrink it, I'll cut this down to just 3 grades. Percentage 1 and percentage grades 2. Okay, so we'll get the total. How do you get an average? You divide them by the number that are there. So average equals total divided by. Now, how do we know how big this array is? Because it could get bigger and it could get smaller, couldn't it? If people add different things. I could put 3, and if I print average, because I forgot, if we print average, that's the average score. 20, 40, and 100, that's the average. Awesome. But if I add another element to this, like 150, I won't put it in here, but you can see that it kind of, and pop it in there. Percentage grades 3. Add those in. It doesn't make sense. 103%. I didn't think you could get. I mean, there are some smart kids in year 10, right? But I haven't seen anyone get 103%. It's not going to work. So the best way I would suggest would be to use a function that we may have used in the past. You may have used in the past, but we haven't used yet, and that is len. Len gives you the length of an array. Super handy, especially when we're doing loops with arrays, which we will in a minute. If we do len, percentage grades, that will automatically give us the amount that we've got in there. So let's check it out. 53%. Amazing, because len percentage grades is the amount we've got, which is 3. Super, super useful. What if we just wanted to check the first grade in here for some reason? If we wanted to just check the first grade, make sure that it's greater than 0, we could do if percentage grades bigger than 0. Is that going to work? Nah, because those are 3 different numbers there. We need to give an index. If we want the first element, we put a 0 in there, and that's basically saying is 20 bigger than 0. We print first element is bigger than 0. Let's run it. Amazing, fantastic, beautiful. We got it. Okay, you all right? You all right? Yeah, I sure hope so. This is where stuff gets really, really important. We're going to do looping through arrays. Now, there are two ways of doing this. What are the two methods of iteration? What are the two methods of iteration? Count controlled and condition controlled. We're going to do condition controlled first. So we'll do counter equals 0. We better make our array first, actually. Let's do an array of names. Just do 3. Names equal Sonic, Mario, and Escargoon.
Escargoon, fetch that fork up here! Pick it up yourself, Clowny.
And then what we'll do is while counter is less than, what was the function we used to find out the length of an array? What was the function we used to find out the length of an array? Len. Len, names. We're gonna print names, but what index are we gonna print? Because if I put 1, we're always gonna get Mario. If I put 0, we're always gonna get Sonic. If I put 2, we're always gonna get Escargoon. It's gonna be very sad. So what we need to do is choose a variable that's going up every time the loop goes round. What variable there? Give you a clue. What variable there is going to go up every single time it goes round? Counter. Well done. We're going to pop counter in there. Give it a go. Yes! Get in. Fantastic. Always good to see. That is how we go through arrays using a while loop. But to be honest, that's only useful to a degree. For loops are way, way, way better for doing arrays. Because think about it, you don't want it to be conditional, do you? You want to just go, right, here we go. Go through me array, start to finish, bish, bash, bosh. Okay? So, get rid of the while loop. Let's do a for loop. Let's do for x in range, just like we did in the previous. We're going to start at 0, because the first index is 0. But where are we going to go to? If you said len names, you were right, because that's as far as we're going to go. How much are we going to go up by each time? 1. Good. Print names, and then what's going to go in those square brackets? What's going to go in those square brackets? X. Good. Lol. Fantastic. The last thing we're going to do, second to last thing here, is 2D arrays. Now, 1D arrays are great for simple data sets, like a collection of names, but most data sets are going to involve at least 2 axes, right? So, like tables, you know, names, age, or if we're selling games, name of the game, price of the game, age of the game, platform of the game. You know what I mean? There's going to be lots of different things. So 2D arrays are really, really useful. And a 2D array is an array of arrays. In fact, let's go with the game example and an age rating. No, we'll keep it consistent. Let's do first and second names, actually. Let's do Bob Smith. Okay. That's just a one-dimensional array at the moment, isn't it? How do we turn a 1D array into a 2D array? We put some more brackets around it! Look at that! An array of arrays, that's all it takes. And how do we separate them? Exactly the same as we do with the 1D arrays. We just whack a comma betwixt them. Check it out. Boom! Separate your arrays out. Next one, let's do Debbie Smith. No, it's not Debbie Smith. Applegate. And then as a last one, we'll do, you know him, you love him, Graham. Oh, yo. Okay, we got a 2D array. Amazing. You might say though, Mr. Singer, and rightfully so, how the heck am I supposed to print anything if my indexes don't make sense anymore? If I do print names 0, that's not going to give me just Bob, is it? It's going to give me Bob Smith because it's an array of arrays. How am I just going to get Smith? How am I going to do it? 2D, 2 indexes. 0, 1 would be Smith because 0 is the first array inside the array and 1 is the second element because start at 0 inside that array. How would we get, do it in your head, how would we get Applegate? That's right. 1, 1. Amazing. How would we get Oyo? That's right. 2, 1. Amazing. Oyo. Awesome. You know the basics of 2D arrays. Easy peasy lemon squeezy. If you wanted to change any of these on the fly, for whatever reason, say Bob changed his name mid-program, you could simply address that index. Let's say we're changing Graham Onion to Graham Shallot. We'd just do names 2, 1 equals Shallot. And then print, if we just print names 2, 1 after that. Names 2, 1. It should say Shallot. Amazing. Do you see what I mean? That's how you change it. The last thing we're going to do in this section is really hard, like really hard, like really, really hard. It will be the hardest thing that you see on an exam if you see it, and that's called nested for loop 2D array traversal. Nested for loop 2D array traversal. It's going to mess with your head a bit, but it has come up on a lot of exams and it's worth understanding. Let's keep our 2D array from earlier and just wonder to ourselves, how the flip are we going to output this? Remember before with the for loop we did, for x in range 0, len of array, and we go up by 1 every time, right? If I print names x there, I'm going to be in for a right catastrophe because all it's going to do is print the individual arrays. It's called names, isn't it? Length of names. Run that. It's not going to print the individual elements. I'll only ever get the pairs, the arrays. And in some of the languages, this wouldn't work at all. Python's quite generous with its output of arrays. What are we going to do? We don't need one for loop, kids, because we haven't got one axis anymore. We got 2 axis, right? Because it's a 2D array. We need 2 for loops. They're nested. Nested. We're going to do a for loop inside our for loop. For y, there's the other axis, in range, check this out, this is mad, 0, because these mini arrays, think about it this way, the first for loop is going to go through the big arrays. So, this one, Bob Smith, then to Debbie Applegate, then to Graham Onion, okay? This one inside is going to go through those mini arrays and print all the ones inside it. So let's do 0. We can't do len names, but we can do len names x, because that's the current little array that we are looking at. Going to go up by 1 every time. Now we're going to print names x, y. Okay, check this out. Boom! Get in. Fantastic. Fantastic. We can go through, see every single element, and using a nested for loop is definitely the best way of doing that. Again, probably the hardest code that you'll ever come across in an exam, aside from maybe some crazy function question, but we'll do that in a future lesson. The challenges for this are quite straightforward. They're on the board. I expect, again, minimum of all the E's and the M's attempting. The E's should be easy for you. That's why they're easy. And the H is really tough. You're going to have to use the random module. Google it. It's awesome. I'll give you Mark schemes. Where art thou, fair Mark schemes? Hello, Mark scheme 5A. Make an array of 5 strings and use the print statement to output one of the elements at index 3, the element at index 3. And that's what you need. You need an array, square brackets, output in index 3. You could have called it names if you like. You could have called it whatever you like. It doesn't matter. As long as you output something at index 3. In which case, Hilda, because 0, 1, 2, 3. Next one, we're going to use a while loop to output the contents of the array from before. We're looking for a counter. While counter is less than len names. Len names, I really want to see that. That's really important because if the array changes size at any point in the future and you've hard-coded that to be like, 5 or whatever, that's not very useful. Print names counter and counter going up by 1. The next one is easier, in my opinion, doing it with a for loop. For x in range, 0 len, just like we showed on the examples before, going up by 1 every time, and printing names x. 5D was the first 2D array question, and an easy one, to be honest. It will be in your exam, and it's not hard to understand once you get your head around it. 0, 1 would be Smith. Easy peasy, lemons. Using the same 2D array from the previous question, create 2 for loops that output all the elements in the array. Nice and easy. So we're looking for a 2D array. Then I've left in my print statement from before. That was silly. Sorry about that. Down here, we've got for x in range names going up by 1 every time. For here, we've got for y in range 0 len names x. You must have the x there. If the x isn't there, you're in for a bad time. And finally, print the name of the array, x and y. This last one was vicious, and for those of you that attempted it, I'm very, very impressed. First, you needed to use a random number generator. The random module in Python is excellent. It's really good fun. I've also done a little variable called keep asking. I used a string, but you could have used a boolean if you really wanted to. While keep asking is true, random index first, so this is the first random index for our array, is generated. 0 to the length of names, so that number must be in that range, otherwise you'll get an array out of bounds exception error. Random index second equals random.randrange 0 len names. Again, same thing, just for a different random number. Your random name is first name, it's first 0, because 0 is going to be the first names, and second name, random index second, 1, because 1 is the second names. Keep asking is then asked to see if you want to keep generating a random input. Well done. Skadoosh.
Oh, you know this hold.
If my function doesn't function, is it still a function?
No, we're not doing this again.
We're going to do functions. Juicy, tasty, medium rare, crispy, lightly salted, Chardonnay vinegar flavoured. Functions and procedures, the brother of functions. We're going to look at the 2 types of subroutine, function and procedure. These are your titles. Get them in. words are crucial here. But before we start, let me just tell you, this is by far one of the most difficult things you're ever going to do at GCSE. Back in the day, this wasn't taught till university level, and now it's done at GCSE. That's pretty crazy. Pretty crazy indeed. When you struggle with this, not if, when you struggle with this, please don't be afraid. You're going to be all right as long as you relax, concentrate, use the coding examples I give you, and take it easy and learn. This will not go in automatically. You need to slow down and listen. First, def. Def is short for define. Whenever you see def, you're dealing with a function or a procedure. A procedure is a subroutine that does not return data. No data coming back. A function is a subroutine that does return data. You must remember these differences. You will fail paper 2 if you don't remember them. A procedure does not return data, and a function does return data. Always worth remembering. A parameter is something that you pass into a function or a procedure. For example, down here we've got add two nums x and y. X and y would be the parameters. If we add in 5 and 10, they'd be our parameters. If we add in 203, those are our parameters. Call. Both functions and procedures will never ever run unless called. Kind of like a dog. If you want a dog to come back to you, if you want a dog to run to you, what do? You call its name. If your functions don't work today, or your procedures, and you're having just a mare with it, just check if you've called it. If you ain't called it, ain't gonna come back. Come back, lassie, please!
And we swear never to tell a soul about this place. You swear?
Sigma Skibbity Riz.
Ain't gonna come back unless you say, lassie!
Never mind. Let's eat some cookies. Yeah.
Coding examples with Mr. Singer. Start with the basic procedure and we'll do functions later. They're much harder. First, key word that we use to define a function or a procedure is def. Then we give it a name, just like a variable, like greeting. Then we do some brackets. You'll find out what they're for very soon. Stay tuned. Then a colon, just like every while or if or for. Whenever something's like being defined with indentation, there's almost always a colon. Notice the indent. Do not forget your indentation. Now, inside the indent is where we say what we want to happen whenever this procedure is called, what we want the dog to do when we say the dog's name. Okay? So if I wanted it to say, print, I am having a lovely morning. Print, isn't the weather beautiful? And then we'll do one more. Print, Graham, thin. Okay. Now, I'm going to run this. What's going to happen though? Think about it before you answer. What's going to happen when I press that? What have I missed? Nothing! Lassie didn't come back. The dog didn't come because the dog wasn't called. Our procedure hasn't run because its name wasn't called. Now, don't make this mistake. Lots of kids do. Some people will call it here. And they'll type greeting and be like, sound, run, call it. And nothing happens. Why isn't it working? Why isn't it working? Check your indentation. You can't call something from within itself. I mean, not yet. We do at A level. That's called a recursive function. That's different. Don't worry about it. You can't call something within itself. Not at GCSE. That isn't going to be indented, is it? That's like the dog calling itself. Your dog, Buster, doesn't go... Does it? Doesn't make sense, does it? You call the dog. The dog doesn't call the dog. Put it outside the indentation. Run it. Get in! Come on. What if we call it again, just for fun? Greeting. Wait a minute. It's output 6 lines, but I've only written 3 print statements. That's because I've called it twice. What if I called it 3 times? Do you see? Imagine if this was a like button on TikTok. We don't want to be writing the code for the like button every single time we upload a new video, do we? To the system. Imagine how many videos TikTok gets every single day, probably 1 million or close to it. We don't want to have to reprogram it every time. We just want to call the function that does what we need it to. Or in this case, a procedure. It's really, really handy. It's even more handy with maths. We're going to do a mathsy procedure now. Let's do def minus 2 nums. Let's do num1 equals 10, num2 equals 5. We'll do answer equals num1 minus num2, and we'll print the answer. This is easy for you. You've done this a million times. Go down here. We call it. How do we call it? Say its name. And don't forget the brackets at the end either. Oh, no, I do not want to enable Ask Siri. Stop spying on me. Okay. I spelled minus wrong. Minus 2 nums. 5. Amazing. It worked. What's wrong with this? Can this procedure minus anything other than 10 and 5? Nah. Nah, it can't, can it? Every time I run it, even if I call it twice, even if I call it again, I could call it 1,000 times and it wouldn't matter. Wouldn't matter, would it? It's got 10 and 5 hard-coded in there. We need to do something called parameter passing. Parameter passing. Watch this and watch closely. Instead of defining, let's delete that. Instead of defining num1 and num2 here, what we're going to do is, in fact, let's write it. Let's go from scratch. Minus 2 nums. Let's pass in some parameters. Let's do, just like we did with the for loop, x and y. These can be our 2 parameters, okay? Then we'll do answer equals x minus y. And we'll print answer, okay? Is that simple enough? So if x is 10 and y is 5, the answer is going to be 5. Are we happy? I hope so. Let's call it minus 2 nums. And in there, we're going to pass through our 2 parameters. You were wondering what the brackets were for earlier? Ahaha! We're back to it. Parameters. Let's do 20, comma, 10. So x is going to be 20. See the logic? You see that? And y is going to be 10. Let's run it. We could call it again now. And this program now, from being a complete one-trick pony that can just minus 10 and 5, can do any 2 numbers in the world. Absolute winner. 201. Minus it. Beautiful. You see what I mean? So much more useful. What if we wanted this to divide? That'd be pretty easy, wouldn't it? Instead of minus, change it to divide. And instead of a minus sign there, what symbol do we use to divide? What symbol do we use to divide? That's right, /, print answer, and then just change the name of it down here to divide. 2 nums, 20 divided by 10, that should be 2, right? Get in. Excellent. You see what I mean? Nice and easy. Parameters are awesome. The next thing we're going to do is calling procedures from within a selection statement. So let's define 2 procedures. This is going to be for you buying a copy of GTA 5, which you know you shouldn't do, but most of you have done. So def will do accept, and that can be print. You can have the game. Enjoy. And then we'll do def reject, and that will say print get out your only. Well, you're less than 18. Okay. Now, we need to do an if statement and call it based on that. So let's allow the person to input their age first. Let's do age equals, what data type would age be? Integer. Good. Int, input, enter your age. And then we'll do an if statement. If age is greater than or equal to 18, what are we going to do now? That's right. We're going to call accept. Amazing. However, if the age is not greater than or equal to 18, what are we going to do? Reject. That's right. Reject. Enter your age. Let's do 15. Get in! Or get out, in this case. You're less than 18. If I do that again and I enter 21, we should call the procedure accept, right? 21. 21.
Dana.
What's 9 plus 10?
21.
You stupid.
You can have the game. Enjoy. Beautiful. That is how you call procedures from within a selection statement. Now, we're going to call our procedure from within a while loop. Let's do a gun shooting mechanic. Let's do ammo equals 30. So that's how many we've got in our mag. And we'll do def shoot. Shoot will say our pew-pews. So print. Okay. So we don't have to keep typing pew-pew. Down here, we're going to do while ammo is greater than 0. So while we've still got bullets left, we're going to call shoot. No parameters in this case. And we're going to do ammo equals ammo minus 1. Amazing. Let's run that. And, oh, actually, no. Let's make it even prettier. Let's do a little print. You have ammo, bullets remaining. Let's give it a go. Oh, get in! Superb. We've called our procedure from within a loop. Amazing.
Mr. Singer, you taught us a lot about procedures, but you haven't taught us much about functions, have you?
No, it's because, to be honest, they're the harder of the two, and I've saved it to last. Functions are really difficult to get your head around, so we'll start with a really basic example, but they are so important and so powerful, unbelievably powerful. So, with all the examples we've done we've done something in a procedure, and it's been printed there and then, and it's done with. It's never looked at again. But what if we need to get the information back to the main program? How do we do that? How do we get the information back? How do we return the information back? Like, for example, if we were playing Fortnite and we did a damage calculation function, we pass in the parameters of the gun that was used. You know, when someone gets shot.
Oh, what? Controller player! That is a controller player!
The gun that was used, the bullet that was used, the ammo that was... sorry, the bullet and the ammo, same thing. The gun that was used, and the location on the body where the bullet hit, whether it was a headshot or a leg shot, for example. We could do the calculations inside the function, but if we just printed it, it wouldn't be much use, would it? We got to bring that data back and actually minus it from the person's health bar. We'll start with an easier example than that, though. Let's start with our add two numbers from before. Let's do add two nums. Don't forget the def. Def, add two nums. Pass in x and y as, what are they called? Parameters, good. Don't forget your colon and your indentation. We'll do answer equals x plus y. And this is the key. This is the key between a function and a procedure. A function, what does it do? A function, what does it do? Returns. Return answer. Okay. We're going to call it add two nums. 10 and 20. However, when I run this, we need to put the return value answer into something. We need to take that value and put it somewhere. Where do we store values? Inside variables. That's right. So let's make one out here called answer, and we'll set that equal to the call. So whatever this function returns, which in this case is the answer variable from here, it's going to take that and pop it in here. Let's print answer. Boom. Amazing. I could change those to anything I like. 1020. Amazing. Functions are so darn cool. So darn cool. As long as you understand returns, you'll be absolutely fine. Would you say, Mr. Singer, this example doesn't really make much sense? Give me another one. Well, what if we did? Let's do a function that calculates your GCSE grade. Let's do def, calc grade, and pass in the mark out of 100 that somebody got. Now we'll do if mark is greater than or equal to 90 and mark is less than or equal to 100, we'll return 9. Excellent. Actually, that should be an integer, really. 9. We could expand that going down, copy and paste it. If mark is greater than or equal to 80 and less than or equal to 90, we could return 8. Now we're going to call it and pass in a mark. I won't do all of the grades, or we'll be here forever. Calc grade, and we'll pass in, for example, 95. Now remember, this is a return, so we have to, this is a function that returns, so we need to store it somewhere. Let's call it grade equals calc grade 95, and we'll print your grade is, comma, grade. Boom! Get in. The coding challenges for this bit are vicious. You're going to have to really work hard. It is the hardest part of the whole course, after all. However, I've given you plenty of examples, and to be fair, the easy ones, that they are quite easy. One of them in there even references, just a basic ID check, checking if somebody's above 18 and returning serve drink if they are, otherwise don't serve. Nice and easy. The mediums are a little bit tough, but the hard is particularly vicious. For some reason, it's cut off the bottom there. That's irritating. Let's escape and go down a little bit. There you go. For those of you that want to do the bonus ultra hard challenge task at the bottom, I'll be very, very impressed. Do your best. Go!
Editing Singer here. This is just a reminder for you to click like, click subscribe, enable notifications, and for the algorithm, comment down below onion.txt. That's onion.txt.
Alright, the mark scheme for functions and procedures, otherwise known as subroutines. 6a. Make a procedure that adds two numbers, takes two parameters, x and y, and adds them together and stores a numerical answer. Your procedure then print the answer going to equal to the numbers of 5 and 40. So we're looking for a def, add two numbers with x and y in the brackets. We're looking for answer equals x plus y, and printing the answer. Add two nums, 5 and 40, with the answer being 45. Nice and easy. Lemon squeezy. The next one was just to double any number that was entered into it. Make a function, not a procedure, a function called double it, and return. You could have stored it in a variable like answer equals x times 2 and return answer. That would have been fine, but return x times 2. Doubled number equals the function call, pass in 50 in this case, and then print the doubled number. Again, you can choose any variable names you like, but that's what I chose. The next one is an ID check. So ID check passes in the age as an integer. We do if age is greater than or equal to 18. Serve drink. Here is your brandy on the rocks. Otherwise, don't serve. Decision equals ID check with an 18 passed into it and decision being printed. Beautiful. 6D, we're bringing back the case statements or the match statements for this. By the way, there are two alternative answers for this. You could have used case or you could have used a series of ifs. So we're looking for shape name calc or whatever you called it with num sides being passed in as a parameter. If num sides is less than or equal to 7 and greater than or equal to 3, then we're going to do the check. If you don't check that, you have not validated it. You need to check that it's in that range. Case 3 would return triangle, 4 square, etc. At the bottom, we call it and store it in a variable. Again, that makes it a function because it's returned. And then at the bottom, we have print shape name. Amazing. The next one was actually the same one, just using an if. That's what it looks like using an if. It's very similar, isn't it? 6E is a juicy question. This one is checking how much money somebody's got and returning true or false based on what they enter. Def purchase, passing in money and item cost. If money is greater than or equal to item cost, return true, otherwise return false. And obviously the inputs are both floats because it's money. Can buy is the variable that I call mine. You can call it whatever you like. Becomes purchase with money and item cost passed into it and then print can buy. This last one was pretty vicious. So again, our old friend Mr. Random makes a return. We're going to define funny story and pass in name as a parameter. Then we're going to do choice equals random.random integer between, I've done 0 and 2 because I only did 3 different options, but yours could be however many options you made. Then if choice is 0, do this. If choice is 1, do this, and if choice is 2, do this. You'll notice name is substituted there, so it could be Smelly Paul or Smelly Graham or whoever's name I input down here, here. And then funny story needed to be called underneath. Unfortunately, that's been cut off this screenshot, but you called funny story with name passed in as a parameter. This next one, 6F, is the same. However, wait. I'm an idiot. I put it across 2. I fixed it on the other. I'm so stupid. So yeah, it's 6F. Sorry. Silly Mr. Singer.
Is this a file? File handling.
Question. Would you play your favourite game if every time you turned off your console or PC, you lost all your progress? Welcome to the 90s. That's what we used to have to do. Before we had save files. That's right, files. The thing you use every single day for Word, PowerPoint, Excel, whatever it may be, is also what keeps your games saved. Today, what we're going to learn is a bit more basic than a game save. We're just going to do a basic text file, writing to it, reading from it, and doing a little bit of advanced stuff with arrays as well.
Tasty.
These are your titles for this section. Go! The keywords for this bit are quite rigorous. You cannot be indolent in this. The first one is file handler. You've got to ask the question, right? If we've got a file outside of our program, how do we interact with that through code? How do we do it? The answer is a file handler variable. The idea of this is get a little file handler, call it whatever you want, I call it file handler here, just for the sake of it. And you pop your text file kind of into it. It becomes like a proxy for it. So you can use that to write to the file itself. Super useful. Open opens a file and actually creates it in the case of what we're doing, which is nice when you use the W as a parameter passed through there. We'll do that in a minute. Close is what closes and saves the file. Definitely worth doing, or you'll lose everything. Although Trinket auto closes, which is really irritating because you don't lose your progress, but never mind. Write is what we use to take stuff from our program and write it into the file. Nice little example there with Hello World. Notice the \n at the end there. That creates a new line. And finally, when we want to read from a file into our program, we just use the read command, along with changing the W to an R on our open statement.
This maze is so hard. Maybe it's so narrow at the bottom.
Let's do some coding examples with As I said before, the first thing you want to do is create a file handler variable. Call it new file, call it whatever you like. I'm going to call mine file handler using camel case. I'm going to do equals, and I'm going to set this to open my file. Now, unfortunately, I'm in Trinket and I ain't got no files yet. But fortunately, in Trinket, we just say the name of it. Let's call it myfile.txt. Very important because it's a text file. That's what txt stands for. Do a comma, and then we're going to pass through whether it's going to be write, that's meant to be a W, or a read, write or read, W or R. Because we ain't got nothing yet, and we need to write something to it, we're going to do a W. Now, before we do anything else, let's just run that and see what happens. myfile.txt has appeared. If we click on that now, though, will there be anything inside it? Didn't think so. We ain't written nothing to it yet. That's what we got to do. So, underneath, if I just do the words file handler dot write, and then as a parameter for that function, I pass through the string that I want to write to it. I could do write hello. I love beans. However, sorry, got to keep continuity. Graham loves those beans, doesn't he? Now, if you write something in a Word document and you don't save it, will it stay there? Nah. We need to save it. To do that, we do file handler dot close with a couple of brackets. Run it. Pop over to myfile.txt. Oh, yes! Fantastic. However, what if I wanted to do 2 lines? What if I wanted to talk about Graham's gardening habits as well? I could do, hello, Graham loves singular dandelion. Run it. We pop back over to our file, and there's going to be something sad. It's all on one line. But I thought, just like the print statement, it'd go on multiple lines. Didn't you? No, doesn't. Not with files. Why would it add a new line character? You didn't ask it to. If you want to do a new line character, that's meant to be an N, we do backslash, not forward slash, backslash N. My MacBook's got an American keyboard on it and I can't find the backslash. Backslash N. We do that whenever we want a new line to be inserted. Run it. Check out the file. Outstanding! That's what we want. What if I wanted to write a string to a file? Well, I could create a string at the start. I could even allow the user to input it. Let's do my string. I could even do my sentence. My sentence. No, let's do my string, because it could be whatever we like. My string equals... How do we do an input? Remind me. How do we do an input? That's right. str. Cast it. Input. And then we do enter your string, please. Fantastic. Then down here, instead of putting Graham loves beans or Graham loves dandelions, I could simply write my string. And if we run this, we should go over to my file. Actually, I need to run it first, actually. Enter your string, please. What should we type? Shrek loves donkey. Graham loves dandelions. True poetry. Enter. And then we go over to myfile.txt. We can see that that string has written correctly. Amazing. The next question becomes, how do we get a file into our program? How do we read it? The answer is very simple. Let's go back to our code that we were just looking at. I'm not going to be inputting nothing now. I'm going to do my file handler. In fact, get rid of all that. File handler, open mytext.txt, W. What are we going to change that W to read? Because W meant write. What are we changing it to read? Ah, that's right. Whack that in there. Now, our file handler is in read mode. We can read into it. Let's do line 1 equals, so that'll be the name of our string. Let's keep good practice, actually. Line 1 equals file handler dot read line. I think the line has got a lowercase l, actually. Run that. I've put handler, stupid singer, silly singer. Right. Outstanding. Let's print line 1. Amazing! Look at that! We've just got information from our text file back into the program, stored it in this string, and then printed it. Outstanding! Outstanding! Just undoing that, if we go back to the writing code that we had before, let's make multiple lines here. Let's do Graham loves beans, and then we'll write our string so that we've got at least 2 lines to play with. Let's do my string. Run that. Enter your string, big boy Shrek. And then that's going to enter, that's going to write it. We go over to my file. We've got hello, Graham loves beans, and big boy Shrek. Outstanding. What if we wanted to read multiple lines into our program? Well, if we go back here, and again, we change it to read. Get rid of that. And we go here, and we do line 1 equals file handler dot read line, lowercase l. For some reason, I don't think that's consistent. Then we do line 2 equals file handler dot read line again, and then we print them both. Print line 1, comma, line 2. Let's give that a go. Outstanding. That's how we get multiple lines read in. The last thing we're going to do as an example is writing a file to an array. I'm not going to show you how to read from an array to a file because you can figure that out on your own, but I will show you how to write to it. Let's make an array. My array equals Graham, Bob, Batilla, and Graham's Grahamella. Yeah, that's Graham's wife. They get on very well. If I wanted to write those to a text file in order with line spaces between them, watch what I would have to do. In fact, we're going to use an array. We're going to use an iteration for this. What sort of iteration would be best for doing this? Do you think it would be conditional or count controlled? That's right, count controlled. Well done. We're going to use a for loop. For x in range, start at 0. We'll go to the length of my array. May have to modify that in a minute. We'll go up by 1 every time. What we'll do, very simply, is, well, before that, we need to open up our file, don't we? So file handler equals open. So the name of our file, myfile.txt. And we're opening it in write mode because we're going to write to it. Down here, what we'll do, dead simple, is we'll say file handler dot write, and then we'll do my array x plus, yeah. Then we need a new line character, don't we? Because we want to put a line in between each one. Plus backslash. Again, my MacBook keyboard doesn't have a backslash because it's American, even though it's English. Grab it. Backslash n. And that should write it to each on separate lines. Let's give it a go. Result. So again, look at that if you want to steal it for your screenshots. That's how we write a array to a text file. Reading it is just as easy, by the way. You just set it to R, and instead of write, you're going to read and put those into an array, just like before. The challenges for this section are very simple. Take a look with me. First, we're going to make a file called mylifestory.txt, write at least 3 different lines to it with a \n at the end of each, close the file, screenshot the code. This is dead important for your notes. Screenshot the code and the file itself so that I can see that the writing has happened correctly. Use the read function to read the file into a string called mystory, print that variable. Nice and easy. Use the read line function to read only the first line of your story into a new variable called line1, and then juicy ones down here, the orange ones. Create a new file called names.txt. Fill it with an array of at least 4 different names using a for loop. We kind of did that together. Nice and easy. However, the next one, you're going to use a bit of string manipulation. If you get stuck with that, Google a Python string upper method, in case you haven't been taught that before, wherever you are. And yeah, give that one a shot. That's fun. The last one is really, really fun. I want a 2D array of first and second names. Use the 2D array to write to a text file. All the names, that should say all the names, not all the names, must be on separate lines with the format first name, last name, separated by lines. That's a tough one. Should really challenge some of you. Go for it.
It came on this morning and then it turned blue and then it turned off again.
But the computer's not even turning on and it's plugged in.
So what is going on? Oh, one minute, I'm gonna tell him that you're working on it and telling me the power supply.
Oh my gosh. Dude, have you ever opened this computer up before?
No.
I'm gonna open it up and show you something I've never seen before in my life.
What?
Mark scheme time. So, first things first, with the life story one, we're looking for an open file handler. You can call the file handler whatever you like, it doesn't matter. We're looking for a W there, and write whatever you like. I've talked about Graham loving chips, because he does. And then a screenshot of both the code and the life story. Nice and easy. 7B, same again, except we're going to read it. We're going to whack it in a variable called my story, and we're going to print it and show me the print screen of that. Easy. Next one, file handler equals open mylifestory.txt, read. Line 1 equals file handler read line and print line 1. Nice and easy, just reading that first line. Next one is arrays, 7D, and I kind of showed you how to do this in the example, so it shouldn't be too hard for any of you. Make an array and write to it using a juicy little for loop. The next one, 7E, we're looking for names in caps being declared as a blank array and getting filled in piece by piece using the read line and then a dot opera at the end. If you've converted these to strings first, that's fine as long as you got the same results. And then printing those afterwards. Nice and easy. Lemon squeezy. 7F, I think this was the 2D array one. Yeah, this one was so much fun. I really enjoyed it. 2D array. Gerald, Eggman, Graham, Bookman, Claire Gooseman, and opening it, names.txt with a write. For X in range, same as always. However, this was the challenge. You had to do first name, names X0. First name, names X0. Last name need to be names X1, because again, we're looking at that zeroth, if that's a word, first index, second index, however, going along with the counter as we go, and then a \n at the end to make sure they all went on different lines. Goose.
Are we recording? I sure hope so.
Surprise. Surprise. Exam questions. Mr. Singer, you've taught me how to program in Python and to get a job as a Python developer. Yeah, the basics, certainly. But what am I going to be doing in June or May when I do my exam? What am I going to be doing? I'm going to be sitting there answering exam questions. So best you prepare me for them. Yes, I probably should, shouldn't I? Should get you ready for those exam questions so that you don't fail on the day. That's right. Being able to program doesn't mean that you can program in an exam. I've given you all the building blocks. Now we're going to do some exam questions together. Real ones from real papers. I'm going to give you the question. You're going to answer it. And then just like with the challenge tasks from before, you're going to mark it with the attached mark scheme. And I'll go through it as well, just to show you my thought process. So, these are your titles. Get them in. Go!
Teddy!
Mr. Bean has got bored of the fight and is now rampaging through the city on his trusty armchair vehicle. Superman, still recovering from his wound, chases Mr. Bean through the city as various civilians are mowed down.
Alright, first exam question, children. We're going to Teddy Bear's Factory. Give me the teddy bears. Teddy Bear's Factory. Jim is writing a program to calculate wages of workers in Teddy Bear Factory, right? Wages of workers in a Teddy Bear Factory. The wages, now, I suggest screenshotting this question in. I'll put it there for you. Make sure you screenshot it in, because you're going to need it. And use either the draw tool or highlight, whatever, I don't know what software you're using. You couldn't really highlight it. It's a JPEG, you moron, Mr. Singer. Use the draw tool in Word. That'll be best. Underline. £2 for every bear. So the wages earned by a worker is either £2 for every bear that they make, or £5 per hour that they work. Okay, £5 per hour, £2 per bear. Remember that. Whichever is bigger. Write an algorithm that, check this out, allows the user to input the number of bears and the number of hours worked, calculates the wages for the number of bears made, calculates the wages for the number of hours worked, and outputs the larger of the two results. My advice to you before you start is very simple, and I'll give you a brief overview. Just because it's the first one, I'll give you a brief overview. You're going to need two inputs. One's going to be a float, one's going to be an integer. You can figure out which is which. You can't really have half a bear, can you? Calculate the wages for the number of bears. That's going to be whatever the number of bears is, times by, look over there, what's it going to be? 2. Then you can figure out what it is for number of hours, because it's going to be times by, outputs the larger. You're going to need an if statement there, a bit of selection. You're going to have to choose which one's larger and output it, and then do an else for the alternative. Do your best. 6 marks. Go! Is the mark scheme for that question. Don't pay too much attention to the pseudocode because it's pseudocode. Pseudes, from the ancient Greek pseudes, meaning false. Pseudadelphoi was false brethren. Adelphoi, Philadelphia, city of brotherly love. Pseudadelphoi, false brethren. Pseudocode, false code. Okay. If we look down here, input the number of teddy bears and hours. If you did that, give yourself 2 marks. 2 times the number of bears, so for the number of bear wages. Again, we'll do an example of this in Trinket in a minute. 5 times the number of hours for that wage. Comparing the two, so an if statement, comparing them. Outputting the rate per bear if that's bigger, and outputting the hour rate if that's bigger. Let's go over to Trinket now and do this together. Right, everybody, we are over in Trinket. First, I'm going to do an input statement. I'm going to do numbers equals int input. Enter the number of bears. Easy so far, right? Num hours is not going to be an integer because you can work for half an hour, can't you? Number of hours would be a float. That's right. Input, enter the number of hours. Fantastic. Then we're going to do a calculation. For the bear wages, we're going to do bear wages. Call it whatever you like, doesn't matter. That's going to be num-bears times by something. What is the something? Let's look back at the PowerPoint. Times by 2. Times by 2. Fantastic. Num hours. Sorry, not num hours. Hourly wage. Or hours wages. Call it hours wages. That's going to be num hours times by what? 5. That's right. 5. Below that, we need to now do a bit of selection, don't we? Because if we go back, it says it outputs the larger of the two results. See that there? So what we're going to do is we're going to do an if statement. If bear wages is bigger than hours wages, we're going to print bear wages. However, if that's not the case, we're going to print hours wages. You get me? Fantastic. Now, obviously, this isn't taken into account if the wages are the same, but the specification doesn't talk about if they're the same, so you don't have to do, if they're equal to each other. You could, if you want to. I don't think you'd be negatively marked for it. In fact, it's weird that they didn't put it in here, but it's not in the mark scheme and you don't need it. Give yourself a mark out of 6 for the question. I'll put the mark scheme back up one more time. There's your mark scheme if you want to pause and have a look at that. And there's my answer if you want to pause and look at that for a bit of reference. Next. Right, the next thing we're going to do involves electric cars. If we look over here, a hotel car park is charging £4 per hour. Expensive. If the car is electric, the price gets halved. But wouldn't there be a charger charging the cost? It costs more. Never mind. Logic is not the strong suit of this question. Write an algorithm that takes as... Remember, look at the bullet points. If I can give you any advice when answering these questions, in the exam, when stress is hitting you, your hormones are going crazy because you've had like 2 hours sleep for like 3 weeks and you've got like 19 exams and you're stressed because you're worrying about your future and all that sort of stuff. Just take a chill pill and go bullet point by bullet point. That's my honest advice to you. If you can take it easy and just get the marks piece by piece, you'll be fine. If you look at it and you get stressed, you'll fail, you won't be able to think, and you'll be really sad. So take it easy, de-stress, and go bullet point by bullet point. Take as an input the number of hours the user is parked and whether their car is electric or not. So straight away, I'm thinking 2 inputs, 1 for the number of hours and 1 for whether the car's electric or not. Easy. Calculate an output, the total price. Easy. Repeat continually until the user enters 0 hours. How are we going to do that, eh? Are we gonna loop until a certain condition is no longer true? What kind of loop would we need? Would it be count controlled or condition controlled? Condition controlled, that's right. And what keyword do we use for a condition controlled loop? While. That's right. Well done. I'm looking for 2 inputs. I'm looking for a calculation of the total price based on whether it's electric or not, which would require an if statement. And I'm looking for a while loop to encompass it all in and keep asking for the person's input. Now, listen to me, 2 things. Number 1, whether the car is electric or not could either be a Boolean or a string. In Python, let's be real. You could do it with numbers, but it'd be silly. If you want to do like, is your car electric, Y or N, and store it as a string, that's fine. If you want to do true or false, that's fine too, but I know Python's a bit funky when it comes to inputting Booleans, so it's up to you. The repeat continually until 0 hours is entered, however, if you struggle with that, go back through your document to the iteration section, programming constructs iteration, and look at the while loop challenge that you did earlier that took in the input over and over and over again in the while loop. That'll really help you with this question. This is worth 6 marks. Screenshot that in. Go! Right, everybody, as per, quick look at the mark scheme, and then I'll show you how to do it in Trinket. Did you input the hours and electric... to be fair, this one is such a weird... I think we do the trinket first, then look at the mark scheme on this occasion. Let's go and have a look together. So, first, we're going to input the number of hours and whether it's electric or not. So let's do that. Hours equals, and this could be a float or an integer. I'll do a float this time, but it honestly doesn't matter. Float, input, enter num of hours, or something like that. Doesn't really matter. And then electric, true or false, or you could put car type, whatever you like. And then that would be I'm going to do a string. A Boolean would be better, but for simplicity's sake, so that we don't have to do the weird, entering a blank and stuff, I'm going to do a string. str, input. And is your car electric? Y or N? So they'll put Y for electric and N for not. Calculate and output the total price. So that's going to be simply an if statement. If electric equals Y, or if you did true or a lowercase y, whatever you did, absolutely fine. Okay. In fact, we need a variable called total price, don't we? Total price equals, start it off at 0. Total price equals hours times, what was it if it was electric? Was it, so times 2. Else, and you could, of course, you could do another if, saying if n, but I'm just going to do an else. Else, total price equals hours times 4. So 4 for non-electric and 2 for electric. Okay, awesome. So far, we're looking at 4 out of 6 marks for that. Really easy 4 marks, right? The last 2 marks are coming from the repeat continually. This is where it gets a little tough. You're going to have to follow along with me, okay? First, we're going to need a while loop, of course. While hours is not equal to, and what did the question say? What did the question say? The question said, repeat until the user enters 0 hours. So while hours is not equal to what? 0. That's right. I'm going to indent it. Remember the indentation we learned from the previous lessons? Beautiful. Okay. However, we're going to have a bit of a problem because we're checking while hours is not equal to 0, right? Oh, by the way, I forgot to output price because I'm a stupid man. How do I output total price? Print total price. That's right. This isn't going to work though. Look, big error because hours ain't defined yet. Look at that. Hours ain't defined because before we define hours down here, we do our input. How the heck are we going to do it? How are we going to do it? Well, watch. Hours equals. Can I set this as a default to 0? No. Why? Because if I set it to 0, that while loop is never going to activate because it says while hours is not equal to 0. So I need to just choose a random value that isn't 0. 999, that'd be fine. That rhymed. Run it. Enter the number of hours. 5. Yes. Get in. Fantastic. Let's keep going. 40. No. 160 quid to park my car somewhere? You better be giving me a bed and a bath and a breakfast for that much. Blinking heck. However, what number do I have to enter to stop it? 0. That's right. 0. Unfortunately, it still asks if it's electric, which is annoying, but it stops there. If you wanted to avoid that, you could just ask if the car's electric first. See? Yeah, that would have been a better way to do it. So yeah, that is how I would approach this question. Next one. For those of you wanting to mark this out of 6 with the official mark scheme, we're looking at it this way. Input hours and electric as two separate inputs and store these, just like I did. Check if the car is electric with an if statement. Correctly calculate and output the price. Hours times 2 for electric, times 4 for non-electric. Repetition using a while loop, and until 0 is entered, just like I did. Here's their pseudocode example. Emphasis on the pseudo. It's false, so don't worry about end ifs and end whiles. They're not real. But yeah, that's the code they give. And obviously theirs doesn't define hours as a default value, so that wouldn't work in Python. But don't worry about it too much. So yeah, that's the mark scheme, and I gave you my example code again. Something like that. Give yourself a mark out of 6. Whoop-ow.
Smack lip. Whoop-ah. Drop down. Snap.
Politics. We're going to do like a voting booth now. This is fun. You got 3 candidates, A, B, and C. Right? A, B, and C. Take a look at this. Allow voters to enter either A, B, or C. Keep track of how many times each candidate has been voted for. As soon as one person's finished voting, allow next person to vote. At any point, allow the official to type the word "and," which will print the number of votes for each candidate. Ooh. And the total number of votes overall. Okay, see that? So, 6 marks again. Nice, easy 6 marker. Take a look at this with me. Enter A, B, or C. Okay, so we're looking for an input called maybe vote or something like that. Keep track of how many times each candidate has been voted for. I don't want to give you too much more information because I kind of gave it on the last one. You're going to need 3 variables to do that. I'm not going to tell you what data type. As soon as one person has finished voting, allow the next person to vote. So that's just going to be a while loop that keeps asking for an input. Again, just like the last exam question. At any point, allow someone to type in end. So your while loop is going to be while vote is not equal to, you fill in the blank. Once it has ended, it's going to print out the number of votes for each candidate and the total number of votes overall. So you're going to need either one really big print statement or like 4 separate print statements there as well. By the way, if you're wondering how to keep track of how many votes, I'll give you the example for A. It'd be like if vote equals A count equals A count plus 1. See what I'm saying? Same for B count. Do your best. Skadoosh.
Oh, you know this hold.
Alright, this is how I would do it. First and foremost, A count equals 0. B count, equals 0. And C count equals 0. Good. We're going to do vote equals string input vote plus A, B, or C. I could format that better, but whatever. And then it'd be an if statement like if vote equals A count equals A count plus 1. You could have A count plus as well. Okay. Copy and paste that and just change crumbs. And just change A to B, B count. So every time A's voted for, that goes up by 1. Every time B's voted for, that goes up by 1. And then for C count, same again. Just change that to C, C, C. Fabulous. All right, that's great. And then at the end of it, we're expecting it to print out the total number of votes and each candidate's votes. So it'd be like print A got this many votes, then a comma and a count. And then copy and paste. A lot of copying and pasting in this, which is nice. B got this many votes. That'd be B count. And C got this many votes, and that would be C count. Fantastic. However, we're missing one crucial ingredient to this Python souffle. What is it? It's the repetition and the end, the last bit again. First 4 marks are always quite easy on these questions, but the last one, the iteration one, they're always the hardest. So I'm going to wrap most of this, not the A count, the B count, and the C count, because we don't want those to set back to 0 every single time, do we? That would be insane. We want those to be set at 0 at the start and then increases as we go. While vote not equal to end, right? Because that's what it said in the question. We're going to do all of this stuff, okay? Indent it. Not the output, obviously, because you want the output to happen when end is entered. So something like that. Looking good. However, we've got no default value for vote, so I would do vote equals, and then just do a blank string like that. Best way to do it. Let's see if it works. A, and then 1B, and then I'll do end. Outstanding. What did I forget to output? That's right, the total number of votes. Total votes equals A count, add B count, add C count, print. Total votes are total votes. Let's do it again. Again, this is my code if you want to take a look at it for marking purposes. A, and then 1C. And then we'll type end. Boom! Result. Happy? Me too. Take a look at the mark scheme with me. If we look, initialization is A, B, and C is 0. Did we do that? Yeah, we did. A, B, and C are set to 0. Fantastic. Allows the input of anything from the user. Incrementing A, B, and C, depending on the input. Increment is a posh word for go up by 1. Down here, or by a certain number, but in this context, it's up by 1. A count equals A count plus 1. B count is B count plus 1. C count is C count plus 1. Don't worry about the elifs. You do not need those. They can just be regular if statements. Stopping only when end is entered. We did that with the not equal to end. And prints out all 3 counts and the calculated total, just like I nearly forgot to do. That's their example pseudocode. Again, that's false code, pseudes, false. However, it's a pretty good structure. I'll give them that. You don't need stuff like end while or end if. That's not real. It's pseudes. There's my code. There's their code. Next.
Oh, brother, this guy stinks!
Now, for this one, I don't want you to use trinket. You say, what? Mr. Singer, I blimmin' love a bit of trinket. Too bad. No trinket for you. Because there's a 2D array here, and I don't want you to have to make an array that big. I'd rather you just do the question in your notes, screenshot it and answer it underneath. Let's read it together. And again, just do it as if you were in the exam. Don't use trinket. Heath is researching how long to the nearest minute each student in his class spends playing computer games Fortnite in 1 week, Monday to Friday. Shouldn't be doing that. Save your games for the weekend. Just kidding. Practice what you preach, Mr. Singer. He is storing the data in a 2D array. Okay. Here's his array. Student 0, for example, on day 0, which is Monday, as we can see here. Monday is day 0. Student 0 played for 60 minutes. Student 2 on day 0 played for 45 minutes. Student 1 on day 3, which would be Monday, Tuesday, Wednesday, Thursday, they played for 10 minutes. Do you see? Good. Heath has the day of the week stored as a number. For example, 0 is Monday, 1 is Tuesday. Write a subprogram that takes the number as a parameter and returns the day of the week as a string. Please, 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 before you try and answer this, go back in your notes that you've made on this and look at the functions and procedures section. Functions and procedures is the one just before file handling. Have a look and try and remember how to do parameters. Okay. Now, bit of advice for this question because it's the hardest one we've done so far. Takes the number as a parameter and returns the day of the week as a string. Remember parameters like on add two nums, x and y were the parameters. What are you going to pass through here? You're going to pass through the number and return the day of the week as a string. Now remember, 0 is Monday, 1 is Tuesday. It's going to be as easy as writing a subprogram. And by the way, it returns. So is it a function or a procedure? If it returns, is it a function or procedure? That's right, a function. We're going to need a return statement. So, don't want to give away too much. Def is obviously the first word. Give it a name, pass in the number as a parameter. Then you're going to need a few if statements to decide, like, I'll give you the first one as an example. If whatever you've called your parameter equals 0, return, in quotes, Monday. See what I'm saying? 5 marks. Screenshot that in and do your best. You don't need Trinket for this. Go. Right, everybody. There are two ways you could have done this. One with a switch and one with ifs. So don't get scared when you look at that. It would have worked fine with if statements as well. If we look at this. Appropriate declaration of a function that takes a day number as a parameter and returns day. Use of selection, if or switch. So if you've got an if or a switch in there, give yourself a mark. Appropriate comparison. So for example, if whatever you've called your parameter equals 0, return Monday. And you need a case default as well, which in a case statement would be, it's like underscore colon. I've had like 2 hours sleep because my baby was sick last night. I can't remember what it is, but it's like underscore colon, whatever it is. Check your notes. But in an if statement, that'd just be an else. I'm going to make this in Trinket real quick just to show you how to do it. Def. That's what we're looking for. You could call it day of week or whatever you like. Doesn't matter. You could call your parameter day. Doesn't matter what you could call it X. Doesn't matter. If day equals 0, return Monday. Do you see what I'm saying? It's that simple. If day equals 1, return Tuesday. Okay, you get what I'm saying? The only thing that they're looking for at the end, obviously you do this for Monday, Tuesday, Wednesday, Thursday and Friday to get all the marks. But at the end, a little else, or again, a default case that says something like return error or day not found, something like that. A difficult question, but not a lot of coding to do. Give yourself a mark out of 5.
What the heck is going on you?
Really? This is our last exam question of the whole course, and it's a doozy. Video game addiction. It's a tough thing. I used to be addicted to games. Still am, especially Skyrim. I love Skyrim. Come across. The truth is, for Steve to get to me, like the time that it beat a chess grandmaster. Dogs, 40 degrees. But I'm going to show you some bad stuff. Imagine what this is going to be like in 1, 2, even 5 voices. Recent studies have shown this is Steve. Steve is my noble steed. The things I do for you. Appreciate this video. Heath is researching how long to the nearest. It's the same context as the previous question, same array. For example, yeah, you get this from the previous. Heath needs to work out the average number of minutes spent playing computer games each day for the class, which contains 30 students. Write an algorithm to output the average number of minutes the whole class spends playing computer games each day. This is a doozy. This is really, really difficult. You don't need to do this in a function or a procedure. It doesn't say that. It just says write an algorithm, which is basically just saying write the code to do this. Now, you're going to have to loop through a 2D array using for loops. 2 for loops specifically, nested for loops. You're going to get a total at the top, total variable, that will keep track of the total. Add to it as you go. By the way, if you struggle with this, again, go back to the iteration section, 3 programming constructs, iteration, pop back there and, get wisdom. Get wisdom. Add those up to the total and then divide by the total number. You know how to work out an average, don't you? That's essentially what you're going to do. The challenge is going to be in the nested for loop. If you struggle, go back again to the iteration section and take a look at what you did. By the way, for this one, you don't have to use Trinket. This is going to be another purely word-based one because obviously I don't want you to have to make the array and actually run it. You can use Trinket if it helps you, but it probably won't. Just do this on Word and we're going to mark it like a conventional exam question. Do your best. What is a programming? Is this a programming? Look, the first mark, is going to be your first for loop. Again, would be like for x in range 0 to len array or whatever it is, and then 1. Okay, they've done it in pseudocode. Ignore that because pseudocode is false. That's what pseudace means. Then we're going to loop the inside of that, which would be something like for y in range array square brackets x. That's really important. And then comma 1. Accessing hours played xy, which is just going to be total equals total plus hours played. They've done x comma y. In Python it'd be x with a bracket, 2 square brackets, and then y with 2 square brackets, which is great. Addition of that to the total, so total equals total plus that. Calculating average correctly outside the loops, so they've done the example of total divided by 30 because there's 30 total students, and times it by 5 because it's over the course of 5 days, and then outputting the results. It's out of 6. I don't know why the previous says it's out of 8. That's a really weird printing error, but it's only out of 6, which is ideal. Well, young scholars, this has been Programming with Sega! In all seriousness, thank you for joining on this journey with me. I hope you've enjoyed it. If you have, check out the Spotify Mr. Singer Computer Science Teacher. That'll really help you with all of the stuff that you need to know. If you need me for anything, contact me. Pop on the Spotify, have a look at those. Yeah, it's been a pleasure. Hope you've enjoyed it, and all the best with your exams. You'll smash it, I'm sure. Thank you so much for joining me, and I'll see you soon.